Okay guys, in the last video I introduced trig identities, and I introduced a method called the Marty method, where I would basically do a change of variables, and then after applying the change of variables, which is x equals cos, y equals sine, tan is y over x, after I apply that, I basically multiply every term by the denominator. And what this does is it actually makes life a lot easier for yourself. You're able to prove trig identities in a more systematic way. So it may not be necessarily algebraically easier, but if you can follow the same pattern, you should be able to solve most, if not all, trig identities. So we're going to apply that here. So just remember, if tan is y over x, tan squared is y squared over x squared. Okay, so we got y squared over x squared minus 1 over y squared over x squared plus 1. So remember, the goal here is to prove that left side equals right side algebraically. So here, the denominator, okay, is y squared over x squared plus 1. So I'm going to multiply both sides by that. Oops. Okay. So I basically moved that term over, okay, and I'm left with y squared over x squared minus 1. Now it's clear to see that in this case, the denominator is actually x squared, right? So guess what? I'm going to multiply both sides by x squared. Okay, so in the next line, I'm going to do just that. I'm going to place x squared right beside the leftmost bracket. And I'm going to multiply x squared to each term on the right. And what that does is it obviously eliminates x squared on the bottom. You know what? I'm going to rewrite that x squared in red just so we're not confused. And what I'm going to do is I'm essentially going to distribute x squared only into the first bracket on the left. Also, the x squared will cancel with any denominator x squared. That's the idea. That's why you want to multiply by the denominator. So in the first bracket on the left, I'll end up getting y squared plus x squared. Okay, I've distributed, and I'm only distributing to one bracket. And then on the right side, I end up getting y squared minus x squared. Okay, now y squared plus x squared, that's equal to 1. Okay, so I end up getting 1 times 1 minus 2x squared equals to y squared minus x squared. Okay, and 1 minus x squared can be rewritten, okay, because 1 is y squared plus x squared minus 2x squared should be equal to y squared minus x squared. Let's see if that adds up. Well, how do I collect these two like terms? Well, that's negative x squared. And I end up getting that y squared minus x squared equals y squared minus x squared. Guys, left side equals right side, and we're all good to go. Okay, so algebraically, this might seem like a lot, but in the end, you're applying the same process to prove that left side equals right side. And so it makes it at least systematically easier to apply. Okay, because what I find with trig identities is that you're kind of left to your own vices, and you have to figure out what is the first step. And by applying this method, you at least know what to do each time until you get the answer. It's the same 2 steps. Apply the change of variables, multiply by the denominator, and expand. See what you get. That's it. So let's apply the method here. So guys, this is a reciprocal function. Okay, what that means is it flips stuff. So what am I flipping here? I'm flipping tan x. Tan x is y over x. So if I apply this reciprocal function, guys, that just means that's x over y. Okay, that's the flip. Here I've got y over x, that's tan. And then here I've got 1 over yx. what I'm going to do here, guys, is I'm going to multiply both sides by the common denominator of yx. That is the common denominator in this expression, in this equation. So I'm going to multiply every term by yx. And now, if I have a denominator that matches with what I'm multiplying by, those terms cancel. So I've got the y canceling over here, and I've got the x canceling over there. And then I got to figure out what I'm left with. Well, I've got x times x, which is x squared, plus y times y, which is y squared, equals 2, and then both these terms cancel, and I've got 1. X squared plus y squared equals 1, which is a true statement. Left side equals right side, and there you go. There's another set of easy to apply methods, easy to apply procedures so that you can solve any trig identity. So once again, it's change of variables, multiply by the common denominator, work it out, see what you get, and that's it. Okay, it's easier to work with x and y alone rather than dealing with secant, cosecant, cotangent, like tangent, sine, cos. It's way easier just to apply this method, and you're not dealing with as many letters, right? Sine x has 4 letters, cos x has 4 letters, but x and y are just 2 letters. So it's easier to at least look at as well, and it makes it a little easier. There's not that much mental blockage. So anyways, all right, guys, thanks for watching. Subscribe, smash that like button, and I'll see you in the next video. Peace out.